Now that we've explored how probability works a little bit, we should talk about the basic rules of probability. So the two basic rules are true for all probabilities. The probability of any event must be greater than or equal to 0, and it also must be less than or equal to 1. In mathematical notation, we write that as 0 is less than or equal to P of, we'll call the event E, which is less than or equal to 1, and P of E just denotes the probability that event E occurs. The other rule that has to be true for all probabilities is that the sum of the probabilities of the outcome, the sum of all probabilities, must equal 1. So if the sample space S is E1, E2, and remember each one of those is a simple event, then the probability of the first event plus the probability of the second event plus, and we keep going, all the way up to the probability of the last event has to equal 1. So let's talk a few definitions. A probability model gives all the possible outcomes of a probability experiment and the probability that each outcome occurs. Every probability model has to obey these two rules up here. If the probability of an event is 0, we say it's impossible. That means it's never going to happen. An event that is certain has a probability of 1. So the probability of an event is 0. That would be like saying the probability that the sun will rise in the west. That's never going to happen. The sun always rises in the east. And a certain event, so a probability of 1, is something like the sun will come up tomorrow, because the sun rises every day regardless of whether or not we can see it because of clouds. So moving on. Another type of probability is an unusual event. An unusual event is one that has a 0.05 shouldn't say that. Jumping ahead of myself. It has a low probability of happening. So what does that low probability mean? Well, generally we say if the probability is less than 0.05 or 5%, we say it's unusual. However, the context is important. If we're talking about some medication that has the probability of some side effect that might kill somebody, then the probability of that side effect happening being 5%, we wouldn't say that's good. We would say that's too high. So, it just depends on the context. So, like, if we had a 5% chance of getting pulled over for speeding, we probably wouldn't consider that a very high probability, and so we would probably speed anyway. So let's talk about the different types of probability. So one of the types of probability is empirical probability. And those are calculated from the results of probability experiments. So, for instance, when you played rock, paper, scissors, that was a probability experiment. So this means one thing about probability experiments is that the events do not have to be equally likely. So the probability of thing A happening could be 60%, and the probability of thing B happening could be 40%. So those probabilities are not the same, meaning they are not equally likely. So there are a couple other definitions we need to talk about here. One is the frequency. So frequency is the number of times a particular outcome is observed. So this is like when you played rock, paper, scissors, and in the video, if you watch it, in my game, player A won 7 out of 20 times. So the frequency of player A winning is 7, because that's how many times we observed player A winning. So how do we calculate the probability then? Well, the probability is relative frequency. And we will talk about that more in subsequent chapters. I just wanted to point out the terminology. So the way we discover that is we take the frequency of that outcome and we divide it by the total number of trials. And remember, a trial is doing whatever experiment once. So, for example, the data in the table below represent the heights of the 2019-2020 University of Tennessee football team. So use this table to answer the questions. So first, we need to know how many total players are on the team. Well, this is our N that we talked about before, our little n, our sample size. which is also the total number of trials, or equates to the total number of trials. So we need to add up all the frequencies. So the way this table works is there's one player that is 68 inches tall. There are 2 players that are 69, 8 that are 70, etc. So we have to add all those up. 1 plus 2 plus 8 plus 13 plus 15 plus 11 plus 19 plus 16 plus 17 plus 8 plus 4 plus 2, and that equals 116 people. So once we know that number, we can calculate the probabilities. Remember, we take the frequency of E and we divide that by the total number of trials, or in this case, the total number of people. So we have 1 over 116, which is approximately 0.009. 2 over 116, which is approximately 0.017. Now be aware, I'm using the little double squiggles. These mean approximately. It means we rounded, and so our answer is not exact. Then we have 8 out of 116, which is approximately 0.069. 13 out of 116, which is approximately 0.112. So at this point, you should pause the video and try to fill in the rest of these probabilities on your own, and then restart the video and see if you got it right. So 15 out of 116 is 0.129. 11 over 116 is approximately 0.095. 19 over 116 is approximately 0.164. 16 over 116 is approximately 0.138. 17 over 116 is approximately 0.147. 8 over 116, 0.069. 4 over 116 is approximately 0.034. And 2 out of 116 is approximately 0.017. So that was an example of an experiment. And our experiment was figure out how many people fall into each height category. So here's another example. 50 shark attacks. Actually, let me stop here because I just realized the video is almost 15 minutes long. We'll pick up with this page when we come back in the next video.